11 today on both of the lines. So yesterday was a lot of on or off the lines, and then if it's on both, that's going to refer to the intersection point. So again, what do you notice? What do you wonder? As we mentioned last time, these are a little different, but last time we went from the center of the bug, it did not work very well for us. So keep that in mind, but just overlooking those, what do you notice? What do you wonder? Georgie?
I noticed that there is no ant on graph 3.
No ant.
Or on the one with 4 seconds.
I think it's here.
Oh, so then there is none on 6 seconds.
Yeah. Yep.
I noticed that the ant is flash and that the ladybug is really slow.
Yeah. Also, as the ladybug seems happy.
Yeah.
I'm not sure about the ant. Is there a mouth on the ant?
No, he just he got stepped on, so his
All right.
face got removed.
Basically, to me, this is looking like two people walking towards each other. Then they meet, and then eventually the ant is just flying. Yeah.
Where did the ant go on number 6?
Where did the ant go? Just off the page. Way over here, somewhere. Yes.
Why is the ant purple?
Why is the ant purple? That's a good question as well. Also, is that a ladybug or Asian beetle? That'd be my question. All right, next page.
Why are you guys traveling at night?
11.2.
Most ladybugs.
Kellen.
Give me a second. I think I hit it. Alright. A different ant and ladybug are a certain distance apart and start walking toward each other. The graph shows the ladybug's distance from the starting point over time, and the labeled points 2.5 and indicates when the ant and ladybug pass each other. The ant is walking 2 centimeters per second. Write an equation representing the relationship between the ant's distance and the ladybug's starting point. And then time.
All right, so who's graphed now?
The ladybug.
The ladybug is graphed, right? Let's write an equation for the ladybug.
L equals 2x.
No. Wait.
Is the slope 2?
2
It's not 2.
plus 2.
Wait, how is it not? Because
Because up 2 over 1 would be right here.
Oh,
it's 4.
up 4 over 2. Okay.
Reduce that.
L equals.
No, up 4 over 2 would be here.
It's
It's 4.
4.
Because it's up 4. Now, it's not. This isn't 1. 1's here, it says. So up 4 over 1. Up 4 over 1. Okay, it looks like 2, but look where the numbers are.
And then plus 2, right? Because the y-intercept.
Is it? Does it go through this line right here?
Oh, so that's plus 4.
It goes through 4?
Oh, wait.
The origin's at 0. Is that it?
Yeah, you can put plus 0 if you want. It goes through the origin. Starts right here. That's all you need for, and you said that was ladybug?
Yeah.
All right. Write an equation representing the relationship between the ant's distance from the ladybug starting point and the amount of time that has passed. So where does the ladybug or the ant start at?
It's a different ant and ladybug.
Oh, it's a different one?
Yeah.
Oh yeah, different ant and ladybug. All right. They walk towards each other. The graph shows the ladybug's distance starting over time. The label point indicates when the ant and ladybug pass each other. So this point is where they pass. So my other line is going to go through that somewhere. I don't exactly know where at this point. But you do know the speed of the ant. Okay, right now I have no idea how that's going to go. But because it tells me the speed, that tells me the slope.
2.
And are they walking towards each other or the same direction? So what is true about the ant's slope, do you think? It's going to be negative. Okay, so for sure I know the ant's slope is going to be negative 2x. Now, just having 1 point, I'm going to erase these other ones, I can figure this out. Because the slope is down 2 now to the right 1. Down 2 to the right 1. And then I should be able to connect the dots. right? Now be careful, down 2, that would be to right here, and then to the right 1. We'd have to go over 2 spots, right, to 3.5. So right here should be a point. What's the opposite of going down 2 and to the right 1?
Up 2 to the left.
So you could also go up to left 1, up to left 1, and then that should be enough information to help me write the line. Okay? So I'm going to connect those. Again, you can use straight edge of whatever you got in front of you. If you ever want rulers, you can get those too. They're back there in one of those bins. So there's my equation. Or my graph, sorry. What's my equation now?
A equals
Y equals negative.
Negative 2x
Yeah.
plus 15. Why is it plus 15? Y-intercept right there. Okay, so knowing that those 2 lines crossed, I could just use the slope and find the equation, and I can find the graph just from that information. And again, I always like to have at least 3 dots, because if they line up 3 in a row, you should be able to connect them. If you have 2, you don't know if you're exactly right or not. So I'd like minimum of 3 when you connect the lines. Did we finish that? If you haven't already, draw your graph. Yep, we did that. All right, question 3. Josh, would you read that one, please?
Elena and Jada were racing 100 meters on their bikes. Both racers started at the same time and rode at constant speed. Here's a table that gives information about Jada's bike race.
Yeah. So Jada. Question 1, graph the relationship between distance and time for Jada's bike race. So we need to, there's nothing on here. Appropriate scale. Appropriate labels. They put time on the bottom, so that'd probably be a good idea to continue. Looks like that's in seconds. This would be distance in meters. All right, what are you thinking for appropriate labels?
6. 2. By,
Colin?
by 2.
1 on the bottom,
Going up?
on the X coordinate,
Yep, how about going up?
on the bottom.
3.
5.
3, are we gonna get to 54?
No.
6.
3, 6, 9, 6? 5s? All right, 6, 12, 18, 24, 30, 36, 42, 48, 54. That's what's nice about going by 6s, right? And the bottom we said 1. All right, put your dots on there, connect them.
Okay. Just that line.
Yep. Now you might say, well, I told you I was like 3 points. Well, there's 2 dots there.
0, 0.
Can find now.
At 0, you are 0 meters from the start. So there's your 3 lines.
Oh, I put
All right, so looking at that information, again, this is Jada. How fast is she going?
6 seconds. 6 meters per second.
6 meters per second. 36 divided by 6, 54 divided by 9. Figuring out the constant of proportionality. She is going 6 meters per second. All right, I believe the questions continue on the next page. Elena traveled the entire race at a steady pace. So we haven't talked about Elena yet, but she's going 6 meters per second. On the same set of axes, graph the relationship between the distance and time for Elena.
Exact same.
It's the exact same line. She's going the same speed.
There.
Okay? So both of them will be on the exact same line. Number 3, who won the race? It's a tie.
Unless there's other people in the race.
Unless there's other people in the race.
Do they not like have the willpower to just like push hard at the end, just like get past the other one?
Yeah.
Why do they have to go to concert like the entire time?
Just.
Yeah, like,
are you-
No one does that in a
No,
race.
6 meters per second.
Are you
An
speeding
electric
up?
bike.
Just a friendly race.
No, or Jonas, an electric bike, you're automatically
Yeah,
going like
they're at the end of it.
All right, take a look at the summary on page 84.
Take a little bit of time for acceleration.
Jonas,
Read the summary.
top paragraph, please.
The solutions to an equation correspond to points on its graph. For example, if car A is traveling 75 miles per hour and passes the rest area when t equals 0, then the distance in miles it has traveled from the rest area after t hours is d equals 75t.
All right, so if you plug in, for instance, 0, your distance would be 0 because 0 times 75 is 0. And then as you look at the next one, if you go 2 hours past that, how many miles will you be past the rest area? 150 miles if you're going 75 miles per hour, which makes sense. Okay, third paragraph, Kellen.
Okay. If you have two equations, you can ask whether there is an ordered pair that is a solution to both equations simultaneously. Dang. For example, if car B is traveling from the rest area, and both its distance from the rest area is d equals 14 minus 65t, we can ask if there is ever a time, when the distance of car A from the rest area is the same as the distance of car B from the rest area. The answer is yes, and the solution will correspond to a point that is in both lines.
All right, so will they ever be the same distance away? Well, when you graph it, they show you what happens there, and then of course you're looking for the intersection point. So 0.1 hours, they'll both be 7.5 miles from the rest area. Okay, they are traveling towards each other. At obviously different speeds. This car is only going 65 miles per hour. All right, so take a look at your homework. Okay, first question. This is similar to the one that we talked about with phones a couple days ago. Yesterday's homework, it was talking about money you're making. I don't remember what they were doing, mowing lawns or something. Okay, so it's the same type of thing. Is there a week when they'll have the same amount of money? So if you're going to use W for week or X for weeks, you're solving for that. And then how much money do they have? You plug it back in just like we did in that homework today. Okay, number 2, use the graph to find X and Y that make both equations true. So you're going to graph them, find the intersection point. Okay, make sure your dots are all lined up for you to see that. It has to be exact. Again, I would do 3 dots per graph so you know for sure where they intersect. Intersects at a nice point. So if you get a decimal, you did something wrong there. Question number 3. Josh, would you read that one, please?
Oh. The point for the graphs of two equations intersect has y coordinate of 2. One equation is y equals negative 3x plus 5. Find the other equation if its graph has a slope of 1.
All right, I think from that information, that's kind of what we started with today. This problem, where we had to kind of piece it together to figure out what the other equation would be. Similar to that one, so we'll see how you do on that guy, number 3. Question number 4, talking about, this is an interesting question. Cows and chickens. Obviously cows have 4 legs, normal cows. Chickens have 2. Together there are 82 cow and chicken legs on the farm. Okay, so there's 82 total legs. And you have to figure out, basically from this chart, if you have 35 chickens, remember chickens have 2 legs. Okay. How many cows are there? Assuming they all have 4 legs, and then you'll fill out the chart.
What an odd way to like keep track of animals.
Yeah.
Well,
How many legs?
I have. I
Make
personally-
go count the legs. Make sure we have 82.
I'm just gonna tell you right now, Farmer.
I mean, I got a cow with 3 legs.
All right, then it gives you more information here in a graph. And then here's the most interesting question. 30 chickens and cows, 82 chickens and cows. How many of them could each farm have? Again, you're looking for an intersection point. That's kind of a fun question. I think you'll enjoy that one. Just remember cows, 4 legs, chickens, 2 legs. Believe it or not, that gets confused a lot on this question.